Dear colleagues, your attention is presented a report on the topic of research, development of a navigation system on the university territory using augmented reality technology. At present, NTU, KhPI, is the largest educational center in the east of Ukraine and the largest university in the city of Kharkiv. About 26,000 students from different cities of Ukraine and foreign countries study at the university. The territory on which it is located occupies 106.6 hectares. There are about 20 buildings on the campus of NTU KhPI. When working with data on the location of the needed object over a large unknown territory with the help of mobile devices, it can be complex and problematic. Therefore, in this paper, one of the ways to solve the problem was propose the development of a navigation system on the territory of NTU, KhPI, based on augmented reality. Augmented reality (AR) is a technology that allows people to overlay a variety of digital content on a real environment. Navigation with augmented reality is an innovative solution. The main purpose of this technology is to provide users with on-screen instructions that are superimposed on top of real-world conditions and that can be seen through the smartphone's camera. By showing the user virtual landmarks in physical space using a smartphone, one can move from point to point more naturally than by comparing the map to their immediate environment. Thanks to this advantage, the AR navigation can help to navigate both inside the building and on the territory campus of NTU KhPI. Previously, it was possible to use the map plan of NTU KhPI, which marked the necessary buildings. You can also use Google Maps to find one of the buildings. It is the most popular SDK for embedding maps in a publicly available application. It is known for its huge database of places and routes. It has all the features for mobile devices, geocoding, directions, images, street view and location information. Users are absolutely comfortable using Google Map because they are familiar with it. The next slide lists the advantages and disadvantages of Google Maps. Advantages: a large database of places with full information, geocoding, routing, permanent visual adjustment. Most smartphone and computer users are familiar with the Google Maps interface. Excellent quality of global and local data, multilingual support, street view. Disadvantages: hard to render, the first time rendering freezes for a second. Recharges the battery and requires some workarounds to improve power consumption. Markers and forms are 100% static. Road routing, not open source. Several options for customization. The Google Maps API now supports limited capabilities to create a unique look for your integrated maps. No open source API. Unpredictable price changes. Information about objects on the territory of NTU, KhPI, can also be obtained from the Mapbox server. Mapbox is an advanced and flexible mapping service that can be integrated into mobile applications. Developers have access to complete location information to create and customize dynamic and static maps with Mapbox tile sets. While Mapbox isn't completely free, it does have a generous free tier in its pricing packages, making the service attractive for apps with a small number of users. On this slide lists the advantages and disadvantages of Mapbox service. Advantages: well-organized documentation, easy card editing, visually pleasing base map, easy to integrate into mobile apps, customization and flexibility. Design and development in the Mapbox Studio and Mapbox API are hard to beat. Fast loading and high performance, especially with large amounts of data. Offline mode in the API, standardized data processing. Disadvantages: focused on larger projects, may disrupt existing background processes. The API cannot be configured. After a comparative analysis between Mapbox and Google Maps for navigation, Mapbox maps were chosen. We form files with the coordinates of a particular building in a certain format on the Mapbox server. According to them, it is possible to build a route on a map. The AR Foundation platform was chosen to support virtual development. It is mainly used for AR development on iOS mobile devices with ARKit support or Android with AR Core support. Also, this AR development toolkit is another good option for developing AR applications for tracking images, 3D objects or 3D scanning. AR Foundation allows to work with augmented reality platforms in a multi-platform way within Unity. The AR program included the display of virtual 3D objects. The 3D design tool was Unity 3D, a sophisticated game engine that allows you to create 3D scenes and simulations. Using Unity, navigation objects and a user interface were created, an application design was developed, a system was implemented to search for buildings on the virtual map of NTU, KhPI, already from the list of those added to the program, and a map with buildings of the NTU, KhPI. On figure on the left shows the making of coordinate points markers of the location of educational buildings on AR map of the territory of NTU, KhPI. On the right is shown the route between the educational buildings. This is a sequence of line segments that a user must traverse to arrive at a destination point, starting at the starting point of a route. Each segment is called a route step, and it is defined by 2 geocoordinates along with the instructions that the user must follow when driving along that route step, as well as some additional data. The actual route between each step does not have to be a straight line segment, but may have its own complex geometry. The authors decided to use a hard-coded route, which is defined by 2 points, from, and, to, determine where the route begins and ends, respectively. The authors showed that using the functionality of AR Foundation and Unity, you can create such a function as routes in navigation. This function integrates with the Mapbox Directions API to create routes with augmented reality in real time, allowing the user of the application to view directions and navigation instructions. The map interface can be used to place markers on a map with bind AR and GPS location data to these markers, and export a file with the generated data for use within Unity 3D. In this case, to determine the location of AR and GPS, the developed module is connected and automatically creates objects in certain places. A map actually developed by the authors based on augmented reality technology will help new visitors navigate the territory of NTU KhPI, find the location of the desired educational building and see the shortest and optimal route to it on the map. Real-time synchronization of actions will allow users to experience the virtual space on the smartphone screen and thereby increase the thrill of development. Thank you for your attention.